So anyway, so good morning. Appreciate you guys all coming out early for what should be a fun event. Mike kicked us off really well. My name is Greg Quiggle. I run product management for Kratos Space. I've been here for about 5 years. In fairness, I did not understand the extent of the adventure I was joining when I came here about 5 years ago. So, what we're going to do today, we're going to talk a little bit about some things going on in the industry. And then from there, I will tell you, we're going to do just a little bit of a shameless product pitch, but I bought you breakfast, so that should be allowed. And then from there, what we're going to do is move into a demonstration. And we're going to let Mr. Carlin from AWS bring it home. And all in, we should be in and out of here by 8:30 or so. So really the goal of the event isn't for you to listen to a product pitch. The goal of the event is for you to actually leave thinking a little differently about how to do ground systems, right? We want to put a couple things in your mind just to think about, right? Because there's a lot of FUD out there in the industry about the changes that are coming, and many of are already upon us. And so we kind of feel like we want to take the role of essentially the innovator in this case. So we'll see how the session goes. And then from there, if you have any follow-up questions or you'd like to schedule a meeting with us, we'd be happy to. Can you turn me down just a little bit? Nobody wants to hear me that much. Okay. So let's just kind of start off with some things that are going on in the industry. It's really a crazy time of new innovations in the industry. So we'll start with new space, right? We now have LEO at scale. We have OneWeb. We have SpaceX with the Starlink constellation. We have at LEO, we have MEOs with mPOWER and O3b. And we even have the large GEO players, right? We have Intelsat having filed for an NGSO constellation. We even have Mr. Dankberg finally admitting GEO isn't enough, right? I couldn't believe it when he went on record with that. So it's a crazy amount of innovation, largely driven by multi-orbit. And the stat I was actually amazed by, where's Stuart at? Mr. Chairman. Stuart, raise your hand. Thank you, Stuart. The stat was crazy. Of all of the satellites, active satellites on orbit, what percentage are SpaceX? 59%, right? That is insane, right? So there's also a whole conversation about launch that comes into play here as well. But huge changes on orbit. Right along with that, along with that growth comes a lot of really new players, new entrants. How many people have read something around direct-to-device lately? Right? You have the folks like the AST Mobiles of the world, definitely making people think space is a little bit more like mobile network. So a lot of changes on the new entrants. Along with that, new business models, right? So I'll use Starlink for this example. Where's Mike at? Mike, so you get the joy of paying the bill for our CEO's Starlink terminal. So how much is that per month? They increased it to $120. What was it when he first signed up? Yeah, $99 a month. And what was the sign-up fee? $600, right? So new business models are crazy. I think another really big part of business model changes, and I'll touch on them a little bit today, is this migration from hardware to software, right? Our industry, like it or not, has been built on hardware for 20 or 30 years now. And everyone's business model is based on that. So suppliers make their money on hardware margins, right? Operators oftentimes plan in CapEx versus OpEx for the way they deploy and manage networks. And with this whole migration to software, it drives the opportunity to think differently about a business model. You basically pay as you add customers. So along with that then, new standards. So I am fresh back from Mobile World Congress. I see a couple familiar faces of folks that I met with there in Barcelona. And, one of the big themes of that show was NTN. So we actually now have a much broader voice as an industry. So kudos to everybody in the room for playing a part in that. That doesn't just happen by accident. Many of us have really pushed for a larger role for space. And end-to-end communications networks. And I think that industry has really responded. So a lot of very exciting new demonstrations I saw for 5G NTN. and a lot of promise that comes with supplier interoperability, much better scale, much better security. I think the coolest demo I saw while I was there was a MediaTek device that was direct to KU, right? Looked like a large Apple phone, right? It was actually demonstrating direct to KU air interface. Really cool stuff. So it just kind of gives you a glimpse again of things to come. The other big thing actually at Mobile World Congress that caught me a little bit off guard actually, we have been looking at it for a while, but I didn't expect quite the push, is AI. So everybody and their uncle says AI. Very few know what it really means to the network. But I will tell you, there's a lot of opportunities to leverage AI and inferences to actually better manage or optimize a radio access network. Getting huge amount of emphasis right now with 5G terrestrial networks. And if we structure our ground systems right, we're set up to very much take advantage of those benefits with space networks going forward. So a lot of changes, right? And some of us can look at that as exciting, right? Some of that we can look at that as terrifying, right? If we dig deep down inside, we all probably look at it a little bit both ways. And I certainly do as a product manager. My unfortunate job is to predict what this world's going to look like in 3 to 5 years. And that's a really hard thing to do. So 5 years from now, what's the ground system really going to look like? So is it built on a new standard? Has the world moved to 5G NTN? Not sure, right? Really good progress in the standards. If we look at where the standards are today with release 18, and I compare that to what baseline expectations are for a VSAT service, 5G isn't quite there yet. But with every release comes progress. So how will that play out over the next couple of years? Very hard to predict. One of the big promises of that, will we finally get away from bespoke networks? Will one vendor's remotes work with another vendor's hubs, right? Wireless industry has been working like that for more than a decade. One of the big promises of 5G NTN is to enable the same type of economics and scale within the space industry. So will we realize the promise of multi-orbit? A lot of talk about multi-orbit. When you look at some of the solutions that are out there today, I get made fun of all the time. I call them Franken terminals, right? So you have a lot of times a couple antennas, a couple modems, maybe a router or a load balance behind it. Over time, though, we see huge advancements in modem technology with virtualization. We see huge advancements with antenna technology. So how will that play out over the next couple of years? I think the promise of multi-orbit is pretty good. Will we actually see AI play a role? A lot of the tuning for a network nowadays in the space industry, it's manual, right? And in many cases, even the provisioning of a terminal is manual. Right? Artificial intelligence can actually do a lot to improve with that if we structure our systems properly to take advantage of the data that's mined from the system itself. Right? Just think of a common terminal issue. Right? You certainly don't want to go to the terminal. That might involve a helicopter ride. But why is the terminal not performing? Is it weather? Is it mispointed antenna? Is it a bad cross-pole adjustment? Is the subscriber over demanding the link that's been designed? There's lots of different things that can go wrong with a service. Leveraging things like AI to not only help you troubleshoot those things quickly at scale, but also be able to fine-tune the network in pseudo real time is a huge opportunity for us, especially at a time that bandwidth is very constrained. So I bring all of this out, again, hit a little bit on the excitement, but also hit a little bit about the terrifying, right? These are really huge things that can impact our businesses over the next 3 to 5 years. And when we look at it that way, we have to figure out how do we navigate? How do we navigate the new? And I think the primary point that we want to do today is just to get you thinking a little bit differently about a way to do it. And I would just say, as you make investments in ground systems going forward in the next year or two, you really want to think about flexibility and investment protection. Pick the platforms now that allow you to support this uncertain new that is coming, because it is absolutely coming. So with that, warning, product pitch, right? With that, we're going to talk about a little bit about OpenSpace. So we kind of view OpenSpace as a fresh perspective on ground systems. And we put a couple key things built into the system that really provide that perspective. So the first is OpenSpace is deployed entirely on mainstream general purpose processor, or x86 processors. There's no FPGAs. There's no GPUs. There's actually no ASICs, right? So at the end of the day, you say, first off, you say, is that really even possible? So we have a couple slides that will show you how possible it is, but we will also give you a demonstration today just to highlight it. What that really gives you, though, is best-in-class flexibility, right? So when you deploy an OpenSpace system, you're buying a mainstream server. You're not buying a hub. You're not buying a modem, right? At the edge of the network, it's actually a UCPE, Universal Customer Premise Equipment. It's the same type of appliance that the terrestrial telcos went with about 10 years ago, right? And what we've really done is through innovation at Kratos, we've allowed you to actually virtualize modems, modulators and demodulators, and deploy them in that environment. So when you go mainstream GPP, what's the real benefit of it? It makes the system multi-cloud ready. So multi-cloud ready means I can deploy my virtual modems in public cloud, like we're going to demonstrate today with somebody like AWS. I can deploy them on a private data center, so I can deploy my own servers and manage them myself as a private network. Can also deploy them all the way out at the edge of the network. More importantly, I can flexibly move them, right, over time. And that's really the key theme that we're going to talk about in today's breakfast. So when you do that, it allows your operational model to be very elastic, right? One of the hugest benefits of cloud is its elasticity, right? If you're not sure what your demand's going to be tomorrow, you're not sure what your demand's going to be in a month, really hard for you to go out and procure hardware to run your network. Typically what you're doing is placing a bet, and you're basically buying to what that peak demand looks like, and you're crossing your fingers. Right? When you run things in software, especially in a cloud environment, you can actually scale up in a period of seconds, right? So over time, that might not be the primary way you want to run your network, but it's a great way to start your network. And then when you're multi-cloud capable, if you achieve consistent or persistent customers, you can start to move some of those workloads to a private data center on your schedule, not on the customer's schedule. Right? You can even start to leverage some of those things all the way out at the edge of the network. So in doing this, it allows you to have a business model that scales much more effectively with customer adoption. It allows you to be very flexible about the way you invest and manage your infrastructure with some likely combination of public cloud, private cloud, and edge cloud. So if we talk a little bit more specific about the way OpenSpace works, one of the things we're launching this week at Satellite is a small footprint get started platform for OpenSpace. So some of you that have seen OpenSpace in the past, we've focused very much on large networks and high availability, right? Two factors that are critical for many in the room. What we've found in our journey, right, over the last years, there's a lot of people that would just kind of like to get started smaller, right? So what we put a lot of effort in over the last year is to actually define an architecture that's a much smaller get started. And we have that displayed here on the slide, and we're actually going to, we're providing demos of it this week, and it's really a key part of our announcements. So what it really is it's a 250 megahertz starter bundle. So 250 megahertz of instantaneous bandwidth runs on a single server, right? We actually have the machine there in the back, right next to Stuart, Mr. Chairman. And so it's a single one rack unit Gen 5 Intel server. It's running a 250 megahertz channelizer in software. So it channelizes and combines. It has multiple virtual modems running on it on the same package. And where's Thad at? Thad. Third-party applications, it has ZipLink running on it. It also has Cloud Junction, correct? Yeah, so one package, no longer do you have to stack a box behind your bespoke piece of hardware to do things like SD-WAN or traffic optimization, all built right in, right? So essentially what you do is you deploy your one server, you pair it with a spectral net, which gives you Diffie conversion, and that is the equivalent of a hub, right? So at the edge of the network, what we'll talk about is a open edge remote. So instead of deploying a physical modem, an ASIC-based modem, what you do, bless you, is you actually deploy a UCPE, and our modem is virtualized. And really the benefit of that, we'll touch on it a little bit later, is investment protection, right? How many of us have to go out and swap modems more often than we would like because we need to go a little faster, maybe a new standard, right? There's all kinds of different variants or reasons why we have to swap modems. Typically, the reason why you have to do it is they're built on application-specific integrated circuits. They're built on ASICs. The ASIC is very good at doing one thing really well. Really, the model here is all about flexibility. So it's less about an ASIC. It's more about deploying a general purpose compute. So you put the hardware out there once. It's actually hardware that you purchase as an operator. It's not hardware that we sell you. And now you have flexibility to deploy whatever software that you need on it. So it gives you a lot of flexibility at the edge of the network as well. So typically the question I get with this is, great, but can this stuff really work on software? And I think my favorite quote from the press over the last year was, yeah, software is really good, but you need a data center to actually run a modem. So I think what we're going to show you today, that really isn't true. Software actually has come a long way. So there's a lot of FUD out there in the industry. What I challenge you is don't just simplistically listen to the FUD, right? Software networks are here and now. We've actually been virtualizing modems at Kratos for about a decade. We started in the US military space. A lot of command and control networks, a lot of Earth observation networks run on OpenSpace technology. We have about 100 production networks deployed around the world, running at scale. Really what we're talking about here at this show is our extension from that baseline to SATCOM. So when we started this journey, three years ago for SATCOM, I will tell you I was a little nervous. We started on Intel Gen 2 processors. And I never told Phil, my boss, but I wasn't sleeping well. And the reason why I wasn't sleeping well is if you look at the vModem density that you could run on a Gen 2 processor, it was okay, right? Very, very application specific, very exquisite type use cases, it would work. Then along came a Gen 3. Kratos didn't really have to do much to take advantage of Gen 3, but the density doubled in both in performance and the number of modems that I could deploy. And then I didn't even get Gen 3 deployed, and there was Gen 4, right? And what we're displaying now is Gen 5. So the reason why I talk about this is when we do this in software and we run multi-cloud, you can actually let a much bigger IT ecosystem drive the performance gains of the industry. It's not Kratos engineering bottlenecking the performance, right, for the industry. And I have a few charts that I put up here just to kind of show the difference. So the top one actually shows the net gains from 3rd gen to 5th gen. So 1.84% improvement in compute density, right? You can read the stats yourself. The slide below is actually the number of CPUs it takes for us to run a given megasymbol. And if you look at this, the chart is it goes up and to the right, which is what it's supposed to, unless you're talking about cost. You always want them to go down and to the right. It actually shows that we've seen about a doubling of gain in performance just from Gen 3 to Gen 5. Again, very little work for us. So what's fueling this? It's not Kratos, I can promise you that, right? It's a much, much, much bigger industry. The fueling really started with things like online gaming, and it started with video distribution. Now, AI. AI is driving out. Where's Mike at? Mike, what's the Supermicro stock up to these days? Yeah, all driven by AI. Crazy, crazy, crazy investments around AI. And then just coming back from Mobile World Congress, virtual RANs, absolutely driving a lot of the innovation as well. And by the way, a SATCOM link is just another RAN, It's a radio access network. So in many cases, we can now leverage many of the heavy investments that are being made much bigger than our industry around AI and virtual RAN. So today is to talk a little bit about how being all software and seeing these huge improvements in density really enable you to look at cloud as a key part of your network, of your SATCOM network. So what you can do is rapidly deploy. They're going to deploy a modem here today, about 30 seconds, right, is what we'll do. No pressure, Thomas. So that allows you to spin up a modem or a hub on demand, right, in a period of minutes. Many of you, I know because I've spoken to you about it, you miss opportunities because you can't get the hardware there. Right? So one of the first things that you get benefit from in cloud is you can spin these things up in seconds, right? It allows a consumption-based business model. So pay for it when you're using it. When you're not using it, you spin it down and you don't pay for it, right? So it's a consumption-based business model. Plus you get all of these other benefits that come along with a large player like AWS, right? You get global connectivity and a whole ecosystem of tools that you can use to sell as complementary services or to manage your network. Over time, some of those customers might persist, right? It might not be an occasional use service. It might be a persistent service. In that case, over time, you can, on your schedule, migrate those to a private data center that you have operated in your teleport. So you go on-prem over time. This allows you to start to look at a business model that perhaps is more CapEx-based. That might make sense for a persistent network of customers that already exist. It also then allows you, because it's mainstream compute, you can actually share the infrastructure with all of your other mainstream workloads, right? Every on-prem teleport has routers, has switches, has firewalls, right? All of the other elements that run in that other workload, right? Now it's no longer an other workload, it's the same workload. But at the same time, because you maintain your cloud connection, you can still continue to leverage global connectivity and all of those great complementary services that come with cloud. And then over time, you can even expand all the way out to offer unique services at the edge of the network. So this might come in the form of third-party applications. We'll show one today with ZipLink. The world's kind of your oyster when it comes to that. But having more software-based and a cloud presence at the edge also allows you to gather a huge wealth of usage data at a very hard location in the network to get it. Right, especially as the world's gone to spot beam satellites, really hard to get good data about what's going on in a user beam, right? When you actually have a private cloud at the edge of your network, not only can your modem function like it should, but you can gather incredible data about the RF spectrum and also about the usage data at that given terminal. It also really, so it enables cloud. It also enables a much more powerful approach and scalable approach at the edge of the network. So as I touched on already, we can deploy third-party ecosystem applications now at that edge. And with that, we also can get a huge span of remotes. So we have some remotes in the back that we can talk to you about later if you guys are interested. We actually have what we would call a plus remote. So it's a small form factor, looks like a typical desktop modem. And we can scale all the way up to a 3-node high availability machine. That actually looks like a hub that you can deploy when you need local landing rights, right? Or local landing regulations. So really interesting way to think about different types of edges that you can get to the network. Again, no hardware development from Kratos. This is actually just taking advantage of an ecosystem of UCPEs that have been out there for more than a decade. So a couple of use cases where this might play. We'll start primarily with occasional use type use cases. So a great example of disaster recovery. You don't know when the disaster is going to come, so you probably don't have the 5 months to wait on the hardware to enable connectivity during it, right? Leveraging cloud is a great example for an occasional use service with disaster recovery. Another one is fiber backup. Really interesting conversations with MNOs. One of the bigger issues that they run into is they build the tower, they put in the base station, the radios, all of that. They have to wait on the fiber connection to get to the tower, right? So what if you light that tower up over satellite for a period of time, and then when the fiber shows up, you spin down the modems and you move on to something else? right? So lighting up towers when you're waiting on fiber is a good example. Events, satellite news gathering, one of the more classic occasional use type services. First responder networks, very tied to disaster recovery. Again, you're not sure when the responders are needed, so having a network in place on demand is a great solution set for them. And then the last one, and one that we're going to actually demonstrate today, is enterprise network diversity. So this is a case where you actually have a terrestrial service. We're going to show you a carrier Ethernet service that's running through an edge. And when that carrier Ethernet service goes down, we actually spin up a virtual modem in AWS, and you use it for diversity, right? You don't have to play the statistics game, right, and try to guess how many are going to go out at a given period of time. You literally react on demand. So modem link goes down, virtual modem spins up, applies bandwidth, you maintain connectivity for the customer, right? Terrestrial link is restored. The satellite connection now is decommissioned, right? And you stop paying for it on public cloud. So it's kind of an interesting use case. This was a pretty simple one for us to demonstrate. So that's what we're going to shoot to now. So here's a demonstration that we're going to show. If we look at, we'll start first at the far side of the slide. So an OpenEdge remote, it's actually sitting at a customer LAN. And what's interesting here is it's not there just for satellite. This is a UCPE appliance that's deployed at almost every enterprise edge site that you see with any terrestrial carrier around the world. They've been doing it forever. So this, although it actually has a virtual modem on it, it's actually deployed as a terrestrial UCPE. And the link that we're going to show is highlighted in purple here. You have a customer LAN. It's got a primary enterprise connection back to the customer WAN, right? That connection could be Metro Ethernet. It could be 5G. It could be DSL. It could be a cable modem. There's a whole variety of different types of physical topologies that it could be. And it's actually running as a typical service. And then what we're going to do is we're going to show what happens when that link gets lost. And how you can actually provide diversity, link diversity in AWS. So Thomas, I'll hand it over to you, my fearless demo partner. So the first thing we're going to look at here, not terribly exciting, right? We're going to look at, this is a view from ZipLink. So this is a third-party application running on Edge, by the way. No extra hardware. The Edge is right over there in the purple rack. And what it's doing is it's taking in LAN traffic from the customer, and it's deciding, do I put this over my Ethernet connection, or do I put this over satellite? It knows the satellite modem is there, right? But at the moment, the satellite modem's not showing available, right? Because we haven't orchestrated the link. The Ethernet network is showing available. So it's actually pushing all of the traffic over the Ethernet network. And as you would expect, you actually see a nice clean connection. So now what we're going to do is we're actually going to, can you give me focus back? Awesome. Thank you, Thomas. So now what we're going to do is we're actually going to kill that Ethernet link. And what's going to happen is the Edge, and primarily the ZipLink software actually, is going to make a decision to say, okay, I've lost my Ethernet connection. My satellite connection is now active. So I'm going to start to push all my traffic over the satellite connection. So what we're going to do in this case is we're actually still going through the Edge, but it's actually going to go through a virtual modem. It'll go over the satellite link and into what we call a cloud-enabled antenna. So that's marketing speak for a digitizer at an antenna. So at the end of the day, all you really need to do to cloud-enable any antenna in the world is you pair it with a digitizer. This is why Diffie is so important. Right? You can buy the digitizer from anyone. We have one. We tend to like it. It's called SpectralNet. It doesn't always have to be SpectralNet. Right? So what we've done is we basically have a cloud-enabled antenna sitting at your gateway. You can think of it that way. And that gateway is now connected via Diffie into the AWS cloud. So can you actually go back really quick? Yeah, there we go. So now what we see happening, the ZipLink display. If you look here, I think I have a pointer. Let's try this. So the purple line was actually your Ethernet connection, right? So the Ethernet connection died, and what happened in that period of time is we actually spun up. We detected the outage, and we spun up a virtual connection in AWS, right? So now we actually have our diversity path, that green path that is actively running. So Thomas, maybe cut over to Op Center, and let's take a look at the virtual modem. So this is actually a view from our network manager. The network manager is actually running in the cloud. It's running in AWS. So we have some that think that's new and innovative. It's really not. It's been done for a very long time. So our Op Center application is running. And what it is here, it's actually connected to a virtual modem. So to the left, you see the carrier. And to the right, you see the constellation plot. And I'm just a product manager, but I think that's 32 APSK, yes? Okay, so it's running at 32 APSK, 4 to 5 bits per hertz, depending on the FAC that you're using. So this is running in software, right? There's no FPGA modem here. There's no ASIC. This is all pure software running in AWS cloud. So perfect. Thank you very much. So now let's take a little look at what's going on from a CPU consumption standpoint. You got to get back into Rancher? Yeah, no worries. Da, 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 da. Yep. All right, there we go. This is a good little conversation about availability, by the way. So you'll notice the link is still up, right? We should have worked that right into the demo, Thomas. So what Thomas is working on is actually a display from Rancher. It's actually another third-party application. Rancher makes a Kubernetes framework. And that's actually what we use to deploy OpenSpace in. It's running on Kubernetes. And the display that we want to show is what the CPU consumption actually is for that virtual modem. It's not a data center. It's a very, very small percentage. It's actually running on 3 cores. 6 threads is what that modem is running on. So, there we go. So you can see there, so it's a 48-core machine. So it's actually 24 cores, physical cores that are running. And we're using 3% of it. So you can do the math yourself for that modem. Very, very tiny. Right, so if you extract the math out, you put a little data port in there, you're well less than $500 a month if you ran it persistently. Right, in this case where you're doing it on demand, it's actually substantially less than that. So that's really what we wanted to highlight today, to get you guys to start to see, right? Not only does software work, it gives you tons of flexibility and allows you to think about monetizing your networks very, very differently. All right, so then why don't we go ahead, Thomas, let's go ahead and see if the link restores, and we're going to go ahead and kill the SATCOM modem, and then let's go back to that Rancher display that's up. There we go. So very interesting. So the number hardly changed. Right? And what hardly changed is actually the tiny little modem that spun down. So just kind of a very interesting way for you to look at the extent and the scale of the networks. So with that being said, I think what we're going to do now is we're going to stop with the demo, and we're going to hand it over to my esteemed colleague, Mr. Carlin. And he's going to talk a little bit about the broader base of things that can come from AWS when you start to think about deploying a SATCOM network this way. So Bill, I'll hand it over to you.
Thank you.
Thank you, sir. You just need to give him control back. Yeah, you got it.
Good morning, everyone. I think Greg actually covered most everything I wanted to say, because he kind of pointed out everything that's enabled by the cloud shows up in the application and the application of the application, in the sense of being able to put up bandwidth on demand, to be able to leverage the virtual nature of the Kratos architecture such that you could deploy it across our world, 34 regions covering the globe, and be able to provision connectivity in seconds. And so from all of the on-demand type applications that he referred to, there's a pretty significant need for speed. When we have disasters, when we have business recovery situations, when we have SNG urgent requirements, they're all, the sooner they're met, the better they're met. So I think that's some of the leverage that he did a really good job of sort of pointing out. Let me see here. So, you know, I'm an old guy. I've been in satellite since 1988. I was actually at the transition from analog to digital, which was interesting. And as a non-engineer, it was even more interesting. So, but it was always painful. I sold domestic satellite networks for Scientific Atlanta around the world. These were massive projects that took quite a long time to deploy, and were more, in some cases, about real estate than they were about the actual equipment. So it's bulky to deploy networks over satellite. It's expensive. It takes time. There are all kinds of issues related to security because you have so many different breakpoints. Our goal is to sort of eliminate that. And so the way we look at it is if we can virtualize or work with our clients to leverage our infrastructure and virtualize their baseband, their OSS, their BSS, all the systems behind. And then when we can move to a global architecture that sort of mimics the evolution of the mobile network, where we go to common radio interfaces and common digital interfaces, we can truly virtualize most of the satellite backbone around the world. And it doesn't have to be uniform. It can be from various different vendors, and it can be unified in the cloud, either through simple network management or a much broader, more in-depth sort of software-defined network orchestrator. So for us, we kind of map from a capability point of view and a support point of view to the three sort of cases that Greg described about being originated in the cloud, being on-prem, or being at the edge. So we've enabled our infrastructure to support all those particular cases. We understand that on-prem isn't necessarily going to go away for quite some time. And in some applications, it makes a lot of sense. So we have to support all of them, and that's what we've tried to do, and that's what has enabled us to work some pretty interesting edge solutions that are satellite trunked via GEO operators, via LEO operators, and most recently via a MEO operator. Greg made a couple interesting points about how the mobile network evolved. I am a pretty big believer personally, and I think the industry in general understands that the mobile network is a precursor for what our industry becomes. It just takes a little longer because the RF engineering and the system engineering is more complex. But as we see the mobile network break down walls around radio interfaces, around baseband interfaces, when we see the adherence to standard, we get massive cost reduction in the infrastructure and massive increase in capability. We think that's coming in satellite. We don't think it's necessarily a one size solution or that one is better than the other, but again, it's sort of a suite of service offerings, each one different, each one with a different capability. All of those can be unified and supported in the cloud. Here's an example of what happened in the mobile network as it moved to a virtualized architecture. This is an open RAN architecture based on 3GPP standards that we will able to virtualize a radio network inside the cloud for DISH. So again, I'm sort of repeating my friend Greg, but the model is that Kratos proposes to lever here is our model of massive infrastructure deployed globally that's diverse and redundant that enables you to offer service on demand, such that you can actually price to your customer by session, by service rendered. It eliminates the massive investment you normally have to make in every project that comes along, where it's hardware first before you can actually start service. We think that you can lever us on a global basis so that as your enterprise customers move to cloud or continue to move to cloud, you can close the loop in the cloud with them. So I'll leave it at this point. I think there was a couple others on sustainability. We can talk about that later.
Yep, very good.
Thanks.
Thanks, Bill. Okay, so bringing it home. So I spoke a lot about investment protection, right, and flexibility. What we showed today in our demo was a DVB-S2X point-to-point link. That's actually what we're launching at the show. That's what's available today. But a big part of that investment protection is about where we go in the future. So a couple of key things that I want to put in the back of your mind. Later this year, what we'll be doing is actually revving OpenSpace to not just support DVB-S2X, but to actually support TDMA-based networks. We're going to do that natively with an RCS2-based solution developed and maintained by Kratos. We're also going to do that in the form of onboarding a third-party player in the name of HiSky. If you're familiar with HiSky, they do basically narrowband TDMA-based solutions for more transactional networks and for IoT networks. Really excited about that. Both of these actually give you then other on-ramps into the basic tool set that you see from AWS that Bill touched on. Secondly, in parallel with the TDMA, we're actually very actively working on 5G NTN. And probably this time next year, if all goes well at next year's breakfast, we'll be talking about our fully virtualized 5G NTN solution. Don't get nervous, Matt. Matt's in the back there, my head of engineering. So what this is actually a means for us to take that same exact server and edge and not only do SCPC S2X to do TDMA, but also to upgrade it to do 5G NTN. So you might ask, well, what about the SIM card? Yeah, there's already a SIM card on the digitizer in that edge. So what this allows us to do is essentially move to a full software-based system that actually gives you a forward path to 5G as that standard continues to evolve. And as Bill talked about, we'll actually then leverage much of the ORAN infrastructure that they've already built out within AWS as a way to give you a complete end-to-end offering. So hopefully what we did today is, again, the goal was to help you just think a little bit differently. Just rattle the tree a little bit and say, okay, maybe there's a different way for me to plan out my network over the next couple of years. Hopefully we were successful in that. If you'd like to learn a little bit more in a smaller group forum, we have a couple opportunities. We actually have scheduled OpenSpace demos throughout the week. It looks like we have 2 of them teed up today. 11 a.m. and 2 p.m. They're actually in this conference room, and my esteemed colleague Thad and his guys will actually be running those demos. Feel free to drop in. We actually also have 2 theater presentations on the show floor scheduled today, and 2 gentlemen in my group. We have Marcus will be talking about our SATCOM solution, and then we have Kevin Tobias will be talking about our Open Edge platform. And those will actually be on the essentially on the show floor. So those are 2 other opportunities for you to actually experience OpenSpace in a setting that's maybe a touch more intimate for open Q&A. With that being said, what I'm going to do, I'm going to close the session for today. If you would love to give us a survey, we would appreciate it on what you liked about the session, what you didn't like about the session. So the QR code's there. Feel free to fill out the survey, even if you didn't like it. Hopefully you did. And also there's several Kratos people in room. We'll all hang out and be happy to answer questions as long as you guys would like to linger. And with that said, I think we are wrapped. So where is Neil? We good? All right, very good. Thank you very much.